Ever find yourself staring up at the night sky and wondering why we're seemingly alone in this vast universe? I mean, with all that space out there, shouldn't there be someone else looking back? Today, we're exploring something called the Fermi Paradox. So stay tuned. Imagine it's the 1950s, and you're sharing a lunch table with Enrico Fermi, a brilliant physicist. Suddenly, he poses a question that seems to come out of nowhere. Where is everybody? He's not inquiring about the lunch crowd, but rather about extraterrestrial life. This unexpected question sparked what we now call the Fermi Paradox. The paradox is this: our universe is unimaginably vast, with billions upon billions of stars. Many of these stars could host planets just like Earth. With so many opportunities for life to develop, it seems almost impossible that we're alone in the universe. So why haven't we made contact with alien civilizations yet? Why is the universe so eerily silent? This paradox becomes even more puzzling when you consider the concept of time. Our Milky Way galaxy is about 13 billion years old. In contrast, our solar system is only 4.6 billion years old. That's a lot of time for other civilizations to develop and start exploring the galaxy. Some scientists argue that if there were technologically advanced civilizations out there, they could colonize the galaxy in a few million years. And yet, we see no signs of alien megastructures, no signals on our radio telescopes, no extraterrestrials knocking on our door. So, where's everybody? Are we truly alone in the universe? Or are we just not looking in the right way or at the right time? The Fermi Paradox doesn't give us any answers, but it sure gives us a lot to think about. Now let's fast forward our imagination to 1961. You find yourself at the Green Bank Observatory in West Virginia. A group of scientists, including Frank Drake, are gathered to discuss the search for extraterrestrial intelligence, or SETI. During their conversation, Drake scribbles an equation on the blackboard. Little did he know, this equation would become a cornerstone of SETI and our understanding of the universe. The Drake equation is a scientific formula to estimate the number of advanced civilizations in our Milky Way. It considers factors like the rate of star formation, the fraction of those stars with planetary systems, and the number of planets that could potentially support life. But it's not just about getting a definitive number, but understanding what factors are important in the search for extraterrestrial life. Now, if you're traveling through the universe in search of intelligent life, you'd expect to find signs of it everywhere, right? But all you encounter is an eerie silence. This is where the concept of the Great Filter comes in. The Great Filter is a term used in the context of the Fermi Paradox. It's a hypothetical barrier that explains why we don't see signs of alien civilizations colonizing the galaxy. The idea is that at some point from pre-life to a Type 3 civilization, a civilization that can harness the energy of an entire galaxy, there's a wall or filter that prevents them from advancing further. This filter could be anything. Maybe life is hard to start, and Earth just got lucky. Or perhaps life is easy to start, but intelligent life is hard to maintain. It could be that advanced civilizations inevitably destroy themselves, or maybe they choose to explore inwardly, creating their own virtual universes. Now, here's where it gets interesting. If the Great Filter is not behind us, it is ahead of us, which means humanity still has to face it. If it's true, we might want to be careful about broadcasting our existence. After all, we don't know what's out there. And the Great Filter is just a theory. It's one of many possible solutions to the Fermi Paradox. So, where are all the aliens? Here are a few interesting theories. First up, zoo hypothesis. Let's say you're an animal in a zoo, going about your day, oblivious to the fact that you're being watched. Now, apply this scenario to a cosmic scale. What if extraterrestrial civilizations are aware of us, but are deliberately avoiding contact? They're like cosmic zookeepers, observing us from a distance, careful not to disturb our natural evolution. They might be waiting for us to reach a certain level of technological or moral maturity before making contact. It's a wild idea, but it's one possible solution to the Fermi Paradox. Next up, rare Earth hypothesis. This theory suggests that the conditions necessary for intelligent life are incredibly rare in the universe. Sure, there might be a lot of planets out there, but how many of them have the right combination of factors that lead to the development of intelligent life. Things like being in the habitable zone of a star, having a magnetic field to protect against harmful solar radiation, or even something as simple as having liquid water. If these conditions are rare, it could explain why we haven't found it yet. Lastly, we have the transcension hypothesis. This theory proposes that advanced civilizations inevitably leave our universe, possibly for the singularity of a black hole. Imagine discovering a cosmic backdoor that leads to new frontiers, leaving our universe eerily quiet. Yes, it's a mind-bending concept, but then again, so is everything else when it comes to the search for extraterrestrial intelligence. Well, that's it for today. Remember, these are just theories. The real answer to the Fermi Paradox might be something we haven't even thought of yet. But isn't that the beauty of science? There's always more to discover. Now, we'd love to hear from you. What do you think about these theories? Do you have your own ideas about the Fermi Paradox? Drop a comment below. And if you enjoyed this video, don't forget to like, share, and subscribe for more space content. And as always, thanks for watching.